let P be a point on the graph of y equals square root x. Express the distance d from a point P to the point 5, 0 as a function of x. And then we want to find for what values of x is d the smallest. So let's start by drawing a picture so that we can understand the problem better. We want to start off by drawing the graph of y equals square root x. Y equals square root x will look like the top half of a sideways parabola. And we want to express the distance from any point on this graph to the point 5, 0. So let's mark the point 5, 0. So we have the point 5, 0 here. And we want to create a function that measures the distance from this point 5, 0 to any point on this curve. So that point could be here, and the distance between those 2 points would be this, or that point could be here, and we have the distance between those points here. So I'm going to label this point as xy, and we want to find the distance. I want to reduce the number of variables I have, so instead of writing y, we do know that this point is on the curve square root of x, so we could write this point as x comma square root x. And we have a formula for distance. The formula for distance between 2 points is x2 minus x1 squared plus y2 minus y1 squared, and all of that underneath the square root. So I'm going to choose one of the points, 5, 0, to be x1, y1, and the other point, the point that's on the curve, to be x2, y2. And we can substitute that into the distance formula to create this function that measures the distance between a point on the square root graph and the point 5, 0. So substituting those points in, those coordinates in, we would get x minus 5 squared plus square root x minus 0 squared, and all of that underneath the square root. I'll simplify, and I'll multiply out the x minus 5 squared to be x minus 5 times x minus 5. And square root of x minus 0 is square root of x. Multiplying, we have x squared minus 10x plus 25, and the square root of x squared is x. I can combine like terms to get the square root of x squared, and negative 10x plus x would be minus 9x plus 25. So we have a function here that measures the distance between any point on the square root graph and the point 5, 0. And we want to know what value of x, for what value of x is the distance the smallest. So we want a minimum value for this distance, and we want to know what x value produces that minimum distance. Now this can be done in many different ways. I'm doing this problem focused on a precalculus class. So we're going to use a graphing calculator to get the answer. So to do it with the graphing calculator, I'm going to type into the y equals menu the function that measures the distance. So we want to do the square root of x squared minus 9x plus 25, and take a look at the graph. And by looking at the graph, you can see that it dips down and goes back up, creating a minimum value. And there's a feature in the calculator that will give us that minimum value. So I'm going to go to Second and hit Trace, which brings up the Calc menu. And you can see number 3 is the option of minimum. And I need to select a point to the left of the minimum. So I'll hit Enter here. And then I'll move the cursor to the right of that minimum value and hit Enter. And then I would like to guess. So I move the cursor closer to the minimum. And then we can see what the minimum value is. The minimum value would be the y-coordinate of 2.179. And the x that produces that minimum value is 4.9999. So let's round to one decimal place and say that an x of 4.5 will produce a minimum of 2.2. A minimum distance of 2.2. A linear function is given. Complete parts A through D. The linear function is h of x equals 1/4 x minus 3. Determine the slope and the y-intercept of the function. This linear function is written in slope-intercept form, y equals mx plus b. So we can determine the slope by looking at the coefficient of the x, and the y-intercept by this constant on the end. So this linear function has a slope of 1/4 with a y-intercept at the ordered pair 0, -3. We want to use this slope and y-intercept to graph the linear function. To do that, we'll plot the y-intercept at 0, -3, and then use the slope to get to a second point on the line. The slope is the rise over run. So we're going to rise from that y-intercept 1 unit and run 4 units. So we're going to go vertically 1 unit and horizontally 4. And that gets me a second point on the line, and we can connect those 2 points with a straight line. Then we want to determine the average rate of change of the function. Because we're working with a linear function, the average rate of change is constant. And the average rate of change is the slope of the line. So the average rate of change for this linear function is 1/4. Now, using that average rate of change, or the slope, we can determine whether the linear function is increasing, decreasing, or constant. For any linear function that is increasing, it will have a positive slope, decreasing will have a negative slope, and constant will have a slope of 0. So this function has a slope that is positive, and so the function is increasing. We can also use visual inspection by looking at this graph of the linear equation. You can see that as we look from left to right, the y values are rising or increasing. For the quadratic function f of x equals x squared minus 6x minus 7, we want to find the orientation, vertex, axis of symmetry, intercepts, domain and range, and also graph the parabola. And we're going to use completing the square to find the vertex. So we're going to start off by understanding what is the general form of a quadratic function. The general form is f of x equals ax squared plus bx plus c. And to determine the orientation of the parabola or quadratic function, all we need to know is the value of a. A is the coefficient on the x squared term. For our example, the coefficient of our x squared term will be a 1 since no coefficient is listed. With a being a positive value, being greater than 0, we know that this graph, the parabola, will be oriented up. We'll have a parabola that opens up that looks like this. So anytime we have the value of a being positive, the orientation will be up. Then we want to find the vertex, and we're going to find the vertex by completing the square. So we're going to start with our function f of x equals x squared minus 6x minus 7, and we're going to start by factoring out this leading coefficient from the x squared term. In this example, because we have a coefficient of 1, we don't have to do this step. But if there is a coefficient there, you want to factor it out of both the x terms. And you're going to leave that constant alone, and you're only going to group your x terms together. Then the completing the square process begins. You're going to find the magic number, and you're going to find the magic number by starting off with the coefficient of the x term, which is -6 in this example. So I'll do this on the side over here. We start with that -6, and we're going to divide it by 2 and then square it. So -6 divided by 2 is -3, and -3 squared is 9. And that's the magic number that we want to add inside the parentheses. So we're going to add a 9 inside the parentheses, and we need to balance our function by doing the opposite of what we've just done. Now we've added 9 inside the parentheses. We need to consider if there is any number in front of this parenthesis as well. So that would be a 1. 1 times 9 is 9. So to balance the equation, I have to do the opposite of that, which is to subtract 9. So since I've added 9, I need to subtract 9. So this will give me x squared minus 6x plus 9 minus 16. Now I'll be able to factor what's inside the parentheses, and it'll become a perfect square trinomial. So this will factor to become x minus 3 squared minus 16. So what we've done is we've taken our function from general form into the vertex form, and when it's in the vertex form, you can write down what the vertex is. It will be HK. So the vertex for this example is 3, -16. Now there's an alternative way to find the vertex, and that's using a vertex formula. And the vertex formula is that the x-coordinate of the vertex is -b over 2a. And for our function, a would be 1, and b would be -6, and c is -7. So -b, that's -6, over 2 times a, which is 1, would give a positive 6 in the numerator, 2 in the denominator, and that's 3. So the x-coordinate of our vertex is 3. We can find the y-coordinate, k, by substituting that value of h into our function. This would give 3 squared minus 6 times 3 minus 7, 9 minus 18 minus 7, that's negative 9 minus 7, which is negative 16. So you can see that we got the same vertex that we got using completing the square. So we found the orientation and the vertex. Now we want to find the axis of symmetry. And for a parabola, if you draw a vertical line that passes through the vertex, you get a line this line of symmetry. Around this vertical line, the parabola is symmetric on both sides. So what we need to know is the vertex in order to state what the axis of symmetry is. So the axis of symmetry will be a vertical line. The equation of vertical lines is x equals, and we'll use the x coordinate of the vertex to state what that vertical line is. So the vertical line, x equals 3, is the axis of symmetry for this function. We also want to know the intercepts. Let's start by finding the x-intercept. So if we have the function, which is f of x equals x squared minus 6x minus 7, and we want to find the intercepts, we'll find the x-intercept by letting y equal 0. This is written in function notation, so y is f of x, and that would give the equation 0 equals x squared minus 6x minus 7. Let's try to solve this by factoring. X times x is x squared. 7 times 1 would give 7. And if I have a minus on the 7 and a plus on the 1, we've factored our quadratic function. I can set each one of these factors equal to 0 to get x equals 7 and x equals 1 for our x-intercepts. And then we want to find a y-intercept. So we start with our function f of x equals x squared minus 6x minus 7. To find a y-intercept, we'll let x equal 0. So I'm substituting a 0 into the function, which gives 0 squared minus 6 times 0 minus 7. And that is negative 7. So we have our y-intercept at negative 7. So I think we're ready to graph this function and find the domain and range. So to graph the function, I'll plot the y-intercept and not the y-intercept, the vertex, and it goes off my screen a little bit. So since that went off my screen, I got a different grid, and now I can plot that vertex at 3, negative 16. We have x-intercepts at 7, and I think I made a mistake here. This is x plus 1, so this x-intercept should be negative 1. And then we have a y-intercept at negative 7. And keeping in mind that this point here is the vertex, and the vertex will be a turning point for the function, creating a little minimum value in this case. And that gives us the graph of our parabola. And now it's also easy to see what the domain is. The domain will be all real numbers, negative infinity to infinity. And the range, you can see, will start, the range is the y values. The range will start at the vertex, which has a y coordinate of negative 16, and go to infinity. So our range is -16 to infinity. Finally, we want to state where this quadratic function is increasing and decreasing. So if we take a look at our picture, we're going to trace our graph going from left to right. So from left to right, you can see that this portion of the graph have y values that are decreasing, and this portion of the graph have y values that are increasing. And you can see that that dividing point is at the vertex. And we're going to use the x-coordinate of the vertex to separate these two intervals. So we have a function that is decreasing on the interval from -infinity to 3, and increasing on the interval from 3 to infinity. Now I've written this with parentheses. There are different definitions that involve increasing and decreasing, and sometimes the definition includes the endpoint and sometimes it doesn't. So pay attention to the wording in your textbook to decide whether you want to include these endpoints or not. So you might need to have brackets so that the endpoint of that interval is included. Determine without graphing whether the given quadratic function has a maximum value or a minimum value, and then find the value. We're given the function f of x equals -2x squared plus 8x minus 2. This quadratic function is written in general form. General form is f of x equals ax squared plus bx plus c. We can determine whether this quadratic function has a minimum or maximum value based on the value of a. A is -2 for this example. And this value of a is going to tell us the orientation of the parabola. We have a value of a that is negative or less than 0, and that means that our parabola will be oriented down. And when a parabola is oriented down, that creates a maximum value at the vertex. Now, we can find the maximum value by calculating the vertex using the vertex formula. So we usually state that the vertex is the ordered pair HK, and we have a formula for the x-coordinate of the vertex, and that's -b over 2a. So you can see that the value of a is the coefficient of the x squared term, the value of b is the coefficient of the x term, and then the value of c is the constant. So let's calculate the x-coordinate of the vertex. We have b is 8, so -8 in the numerator, and a is -2, so we have 2 times -2 in the denominator. This is -8 over -4, which is a +2. Now the maximum value is actually the y-coordinate, so we need to calculate the y-coordinate of k, and we can get that y-coordinate by substituting h into our function. So we're going to substitute h being 2 into the function to get that maximum value. We have -2 times 2 squared plus 8 times 2 minus 2. We're going to follow order of operations, applying the exponent first. 2 squared is 4. And -2 times 4 is -8. -8 plus 16 is +8. And 8 minus 2 is 6. So this function has a maximum value of 6. Suppose that f of x equals x squared minus 2x minus 15. What is the vertex of f? What are the x-intercepts of the graph of f and solve f of x equals negative 15 for x. What points are on the graph of f? And then finally, we'll use this information to graph the function f of x. So let's start with finding the vertex. We can find the vertex using the vertex formula. And the vertex formula has a formula for both the x-coordinate and the y-coordinate. We'll find h using the formula negative b over 2a. A is the coefficient of the x squared term, and we have a coefficient of 1. B is the coefficient of the x term, and we have a coefficient of negative 2. So in the numerator, we have negative 2, negative, negative 2, over 2 times 1. And this gives 2 over 2, which is 1. So the x-coordinate of our vertex is 1. We can find the y-coordinate of our vertex by substituting that value of 1 into the function. So that gives 1 squared minus 2 times 1 minus 15. That's 1 minus 2 minus 15. 1 minus 17 is negative 16. So we have a vertex of 1, negative 16. We also want to find the x-intercepts of our function. So to find an x-intercept, we let y equal 0. This is in function notation, so f of x is the same thing as y. And we'll set our function equal to 0. 0 equals x squared minus 2x minus 15. Let's try to solve this by factoring. I know that x times x would give x squared. 5 times 3 would give 15. And I would need a minus on the 5 and a plus on the 2 to get negative 15 for the last term and a negative 2x for the middle term. Set each one of these factors equal to 0, and that will give x equals 5 and x equals negative 3. For part C, we want to solve this equation f of x equals negative 15. So using our function f of x equals x squared minus 2x minus 15, we want to set f of x equal to negative 15 and solve. I'll move all the terms to the same side, so I'll add 15 to both sides, and that gives 0 equals x squared minus 2x. I can factor the greatest common factor out to get x times x minus 2 equals 0, and once again use that zero product property to set each factor equal to 0. That gives solutions of x equals 0 and x equals 2. And that means that the ordered pairs 0, negative 15, and 2, negative 15 are on the graph. We replaced f of x with negative 15, and that means that we have the y-coordinate of negative 15 and the x-coordinates of 0 and 2. So we want to take this information and draw the graph of this function. So I've got a grid here. We'll plot the vertex of 1, negative 16. We have x-intercepts of 5 and negative 3. And then we have 2 additional ordered pairs of 0, negative 15, and 2, negative 15. We're going to keep in mind that this is the vertex, which is a turning point of the graph. And we can sketch the parabola of this function. Make that a little bit nicer.